Okay, moving on from previous video part 1. Please watch part 1 if you don't know where we are at right now. So as I said, we split sections from here. So ideally we want to start from left to right. Okay, so when we start from left to right and going right, okay, the first part we cut here is the part we want to stop right before it. So we want to stop at this part. Okay, so it's like legit just stopping right before it. Okay, and that distance from here to there, that point we just stopped at, is x. Okay, so don't forget that. That is denoted here as the distance between this point and this point, known as 0. X is less than 1. Okay, so it's just less than 1. Obviously that equals 0. Denoted as that. Okay, and we want to find V, the force going downwards, and the positive moments in this direction, okay? We know that this is the reaction force A, and we know that this distance is x, okay? So that distance is x. Don't forget, it's not 1, it's x, okay? Now, let's just simply work out the formulas. So this is negative V plus, remember, this is the same as the sum of forces in the y direction equals 0. Negative V plus RA equals 0, where V equals RA. Okay? This is when the sum of moments in the y direction equals 0. Alright. Now for the moments part, we start from here and we go left. Alright? And we include every single force along that sectioned part. So M, remember, M has to be included because M is a moment, regardless of where it is. It's a moment already, so there's no distance that needs to be multiplied by. This is M. Okay, so V, because V is there, it's V times 0, so V is kicked out. Alright? So there's no V here for the moments, alright? Now, that's going to be in subtracts RA, because RA is going in the other direction, the opposite direction to M, multiplied by the distance of X. Now, can you see our function coming up here? Where M equals RA X. There we go. Okay. Alright, that's our first formula there. Alright. Now, the second part, quickly, let's just quickly jump onto it. Now, as I said, just keep going from the beam. So start from there, keep going, and stop right before there. Alright? So right before this point. Okay? Remember, if you didn't understand, just rewind backwards a bit and you'll see why I said that again. Alright? So let's just quickly denote what we're doing here. The limits between 0 and just less than 2. So it's just less than 2. That distance is denoted as this section of the beam. Okay? Remember V going downwards, M in this direction, the 4 kilonewton force there with the 1 meters distance there, and the overall distance of X. Don't forget, guys, that's X, not 2. Very important that you remember that. If you do not remember that, you will have errors all over your working out from here onwards. Okay, so let's just quickly work out the sum of the moments in the air. Sum of the forces in the y directions equals 0, where the negative V plus the RA subtracts the force. Sorry, I'm going fast here, but this is just redundant working out. It's simple math. So V equals RA subtracts 4. That's our formula for V. Okay. Moving on, the sum of moments equals 0 from M. Don't forget, guys, this is from M going left. Okay, including all the forces along. M is included. Don't forget that. V kicked out plus 4y plus, because this in that direction. Why is it in that direction now? Because we're doing about this point. That's the pivot. Okay? So just imagine this pushing it down going, let's just call it clockwise. Okay? So 4 multiplied by the distance of. Now here's the funny bit. Many people get this bit wrong. Okay? This is X subtract 1. Do not forget that. That distance there is X subtract 1. Okay? Just remember that, because the overall distance of X subtracting the distance of 1 will give us the minute distance here. Okay? Do not forget that. Alright? Do not go 1 or x or anything like that. Alright? Because that does not make sense with regards to the sum of moments. Alright? And their distances. So moving on. So we've got 4 multiplied by this distance here as denoted. This is our distance that we wanted to multiply by. And we have the RA multiplied by the overall distance. So this is RA is negative because it is opposing, is going upwards, opposing the moments m. RA multiplied by the overall distance of, voila, x. M, just rearrange, do some quick working out. Sorry, I'm just skipping a few steps here because it's just redundant maths. Okay, so we got our second formula here, right? This is our second part. This is our first part. Now, what about the third part? We want to go from here and all the way to the left. So all the way to the right. Now, let me start denoting it by red. All the way to the right. Now, this is a problem because when we're trying to find V here and M here, it's not going to make sense. It's just going to equal 0. It's going to be redundant. No sense. Okay, so what do we want to do to give us a formula that would denote this part perfectly? Here, right? But we just worked it out. We just worked out the formula here going this way. We're having a bit of a problem here. So what do? I'll tell you guys. The easiest thing about this, the easiest way to work around this problem, is simply going from right to left this time. Okay, so we're going this way now. Alright? And when you go that way, a few problems arise, so the problem now gets a bit more confusing, but I'll just tell you a quick workaround from this confusion that we're getting here. So this is the part we want to work through now. And the limit known for that part, now I'm going to start writing this in red. Sorry, let's stick to black, sorry. Don't confuse you guys now. So the limit defined here is 2 less than x, 2 greater than, 2 less than x greater than or equal to 3. Alright, so less than equal to 3. Getting my limits confused here, sorry about that. So that is simply this small section, okay? And which way does our V go? Wrong. This is not where our V goes, okay? As denoted previously, we know that those will equal 0. Here. But why have I drawn it the opposite ways? Okay, let's just quickly show you something. These forces and moments cancel each other out. This cancels with that. Keep that in mind when you're doing this, okay? When you're doing forces and moments in this direction, and this part, what would it have to be here to cancel here? Alright? So obviously, opposite. Duh. It's simple. Alright? There we go. That is the first hard part done. Now the second hard part is actually knowing what this distance here is. Okay? Now here's a general thing that you must keep in mind now. Overall distance of beam, 3, because we're working from overall distance here to this point defined right before here. Overall distance, okay? 3, which is the overall distance, subtracts the x, the unknown distance that we want as a variable for our formula, the x we want as our formula, okay? Remember, that is the very hard part. A lot of people get that wrong because people keep thinking it's x subtract 3, such as our previous case here. It's not. The reason why it's the other way around is simply because we're going the other way around. We're going from right to left, not left to right. Okay, so let's just quickly work through this. Now, I'm going to just go a bit fast now because I'm running out of time now. So, here we go. We have a reaction force BO here. This overall distance there. Alright, so we're not including forces here, don't forget, because it's greater than 2. Okay, we're not including the moments there. Alright, don't forget that. Same as the previous case. Sorry, we didn't include the moments there again because it was less than 2. Okay, so in my part 3, I'm going to be showing you the final bits and how to draw the actual bending moment diagram. Okay, guys, thank you for watching. Go to part 3, please. If you can't find it, go on my